Hello everyone. Today is the 49th day of Leetcode 75 challenge. Let's begin with the 49th question. Question 215, kth largest element in an array. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. You are given an array of integers num containing n elements. Fine. And our task is to find the kth largest element in the array. So basically this is the array given to you and it has some numbers 2, 5, 8, 10, 3, okay, and the other. The element that would appear in the kth position, the array were sorted in descending order. So kth largest element means if k value is 3, therefore we need the third largest element. Okay. So from this array, what is the largest element? 10 largest. I will write it as largest, right? After 10th, which is the second largest? 8, right? After 8, which is the third largest? 5, right? So k is basically 3 right here and largest. So third largest is 5 in this case. So when we sort this array in descending order, we will be having 8, 10, 8, 5, 3 and 2, right? And from start, this is the largest, second largest, third largest. So k value will be basically the third, second, first or 10th largest element and you have to return that. Okay. And when you are looking for the k largest element, not the k distinct element, please keep that in mind, not the distinct element, duplicate count as a separate element. Fine. You cannot use a full sorting of the array to solve this. Yes, we can solve this problem using just a sort algorithm, but you are not allowed to do so. Okay. So return the kth largest element as an integer. So we have to just return the kth largest element without using the sorting technique. Fine. The constraints of the problems are the k would be from the k and nums of length could be from 1 to 10 to the power 5 and nums of I value could be from negative 10 to the power 4 to positive 10 to the power 4. I hope you understood the problem explanation. It was pretty straightforward and simple. Now let's move to the next slide. Now let's understand the input output explanation. So here k is given as 2, which means the second largest element. We have to find the second largest element, right? Pretty simple. If here you could see 6 is the largest element, then comes the 5. Therefore, the output is 5. And that we have to do without sorting, okay? We have to figure that out. Here k is 4. So fourth largest element, right? Fourth largest element would be, let's write it down. 6 is there, then I guess 5 after that. This one is covered. Then there is 4 after that. There is 3 two times, then there is 2 also 2 times, then there is 1, right? So first, second, third, and fourth largest is the number 4 value is the fourth largest element here, right? So I hope you understood the input output explanation. It's a pretty straightforward and pretty simple. So let's move to the next slide. Before going to the further slide, let's understand what is min max heap or min heap or max heap concept. Fine. So what is a heap? It is a spatial binary tree or a complete tree where the value of each node is either in many case smaller than or equal to its children, massive greater than or equal to its children. So basically it stands like this. This is a tree, and if you're looking for mean heap, how it works, okay? Let's see here. Every parent node is less than or equal to its children. Suppose if this is -1, it will be 2 and this will be 3. It will be 5, it will be 6. Okay. It will be 10, it will be 20. So if you could see, so this is a parent node, and this is smaller than any other node present here for in the children. Okay. 2 is the parent node, and 5 and 6 are its children, and these children are greater than the parent, which is 2 here. That is what is written here. Every parent node is less than or equal to its children. Okay. The root contains the minimum element used when you use to fast access the smallest element. So basically, every parent element will be smaller than the children element, and for the max heap, it will be opposite. Every parent element will be greater than its children element. So here you could see this is the parent element, right? For this, all the children is below it, and it is greater than the all the children present under it, right? If we take 10 as the parent element, 6 and 5 and 8 are smaller than 10. 10, right? Because 5 and 8 are smaller than 10. Similarly, if we take 11 as the parent node, 2 and 3 are smaller than it. So what is written here? Every parent in a max heap case node is greater than or equal to its children. So basically, if this is the maximum element, okay, all its children will be minimum to it. This is the maximum element. all the children below it will be minimum to this, fine. And this will be minimum to this particular node, but this will be maximum to the below children's, fine. This is how it goes. Now, why it's efficient, right? According to the time complexity, if you could see, insertion takes log n time, deletion of minimum maximum takes log n time, and picking of the element takes O of 1 time. Now, here I've done reheapify. Reheapify is the concept of how the heapify thing works in a tree, right? How heapify works. So basically, it means that whenever you delete a node, we have to reorganize the complete tree, right? Or how to delete a node in the middle, or how to delete a node at the end, right? This is what a Heapify does. So this is a different concept or different thing to learn about. I will create a different video for it, fine. A space complexity comes out to be O of n if we store the elements, otherwise 0, okay, or O of 1. Now this is mostly efficient for solving the kth largest, smallest element problems, priority queues problems, median finding problems, and heap sort kind of problems, fine. Where mean max heap is used, okay. So I've written some kind of questions here, or you could say examples of things where you could use this particular topic. Okay, in priority queues, it is mostly used in C++. You could use this concept. Okay, like elements with high priority are served before the lower priority. Priority queue is basically mean heap only. Okay, and max heap. But in uh, Python, if we focus on Python, there is nothing such as a priority queue directly. Okay, so what we do, we use heap queue to solve our min max heap concept problems. Fine, which is the concept of Heapify also here. Okay, we'll learn about this. Now, Dijkstra algorithm uses this min heap concept. Top K problems uses this min heap concepts when we have to find the largest or the smallest element efficiently. Heap sort uses the min max concept and it takes O n log n time complexity. Okay. A median of a string use mean heap and max heap together to maintain the lower and upper halves of the data. So these are the questions, examples, or topics where you could use the mean max heap concept. Okay. So I hope you understood the concept of min max heap. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. So let's do it by understanding the goal first. So we are given an unsorted array of integers, nums, and a number k. Okay. Now our task is to find the kth largest element in the array, not necessarily unique. It is not has to be unique. Suppose if it is 555 and there is 444, and I'm asked to find the k is 5, right? Find the fifth largest element. Okay. What do we do? You cannot just see, okay, we have five, three times, four, three times again. So basically uniqueness is 5 comma 4. We only have two numbers. No, we cannot count it as that. We have to look it serially. If we sort it, what happens in descending order? This is the first largest, second largest, third largest, even if they are equal. Okay. This is the fourth largest, this is the fifth largest. So we will return this. Fine. We're not allowed to fully sort the array, basically not using any kind of n log n time complexity using merge sort, quick sort, something such as. Okay. Instead of sorting everything, we only need to track the top k largest element seen so far. Okay. So since you're not allowed to sort, what we could do? We could just try to track the kth largest element, right? We have to figure that out, how we can, track that particular element. So once we have processed the whole array, the smallest among those k top elements will be the kth largest overall. So what I'm trying to say here is that we can try processing the k elements, okay? Processing k elements and using some kind of data structure that can give us push access to the smallest among the kth largest. So this is a kind of an intuition which is coming to my mind. Suppose if you have an array and if you take three elements with you, okay? If I try to take three elements each time, like a window function, okay? Let's consider it as that way. And if I take the kth largest element from it, I will get a value, right? And similarly, from this, I will get a value another time. Okay. I could do something like that. And for that, to access the element in a faster way, the main thing comes out to be the mean heap concept. Okay. Because mean heap will give me the kth largest element in this particular thing. How kth largest? If you have the mean heap of size 3, let's take it as size 3. Okay. Was 2, 1, 6 or whatever. And it will be organized to, if I take mean heap, it will be organized to this 1, 3, 6. If I pop one from it, then what does it say? It says that kth largest element was 1. So I will explain this in next slide. Let's move ahead. Now let's visualize the process. Fine. Imagine we are iterating through the array while maintaining a mean heap of size k. So let me draw an array, for example. Okay. Okay. Let's take this as the array. Let's take the k value to be 2 here. Okay. Now, the heap always contains the kth largest element seen so far. Why? Because suppose if we have a, let's me take a heap here. Okay. This is a heap. Now, what happens is that if I iterate through the array, fine. Just bear with me. If I iterate through the array, I have 3. Okay. I will put it into the heap. Now, size of the heap is what? It's 1, right? No worries. Now I will push to now we will iterate and come to 2, and I will what I will do? I will put 2. So this will get reorganized, and the reorganized array will be 2 and 3. Reorganized mean heap, okay? This is a mean heap. Please keep that in mind. And this is the index 0 always, 0, 1, 2, and so on. Fine. Then I will come here, I will put it in here, and it will be 1. This is an organized mean heap, which is correct. Fine. Now what happens is that since we have to find the kth largest element, which means the second largest element. Okay. Now here we can see the size of the heap is 3, and from 3 to 1, what is the second largest element? It is 2 definitely, right? So what we'll do for getting 2, we have to pop 1, right? So what we will do? We will pop 1 from here. After doing so, what happens? We have 2 and 3 with us, and this heap tells us that we are storing k elements having up to kth largest value. Okay. This heap tells us that we will only store this kth largest value only up to kth largest value. Suppose because 2 is the kth largest value from 3 to 1, right? Definitely. Now, after that, when I move ahead, I will come to 5. Okay. I will put 5 here, right? Again, if I will check the length of the heap comes out to be 3, which is greater than the number of number given to us, which is k, which is 2. I will try to pop 2 now. Definitely, I will pop 2, right? Because this is the nearest one. Okay. Now I'm not changing the index again and again. This will become the 0 index when 2 is getting popped because it gets re-heapify again. Okay. So 2 will be popped out, right? Now if you check this complete array from 3 to 5, what is the largest element? 5, right? And after that, which is the second largest element? 3. So if after popping up the 2, and if I go and do heap of 0, what I will get? Will get 3 definitely. Is that correct? Yes, this is correct because this is the second largest element in this particular sub-array which contains in the heap. Okay, that's why in the heap we are trying to store only the up to kth largest element, and this is how we will do it. Okay, now when I moved here, now it is 6, right? I will put 6 here back. Now I will pop this 3, correct? Now if I try to do heap of 0, I will get 5. Is that correct? Yes, it is correct. If you check from 3 to 6, 5 is the second largest element. Fine. If I come to 4 now, right? If I add it to the queue, heap, I would say. Okay. And after that, what I will do? I will pop it, right? Because the length goes more than 2, which is 3 now. If I pop 4, and if I try to do heap of 0, what I will get? I will get 5, correct? Because if you can check from uh, 3 to 4, the second largest element comes out to be 5. Because 6 is the largest, 5 is the second largest. And even though before storing 4, if you can check uh, from 3 to 6, second largest element also comes out to be 5. So heap basically is helping us to provide us with the smallest element, right? Smallest element in the heap array. Okay. But since we are putting uh, values by values like a sub array, we're just trying to check in each sub array from one size to the x size. What could be the second largest element till that point, right? This is what written here. At the end of the loop, the smallest element in the heap is the kth largest overall, because there are exactly k minus 1 elements in the heap which is greater than it. Right? Definitely that's the thing. So this is what the intuition visualization process is about. How we can simulate this, right? What we could do, we could just create a main heap. First, we have to create an array, okay, or list in Python. A priority queue you could create in C++. Right? We look through each element in nums and add num to the main heap. Definitely. And if the heap size, what we were doing here, if the length was greater than the k, the length of the heap comes out to be greater than k, we pop the smallest element from it. Okay. Then it will give us this. Then the second element would be the kth largest element always. Always. Fine. After processing all the elements, the heap contains the kth largest values, and the smallest of them is our answer, right? Because this contains three elements or four elements, whatever, and these are the fourth. These are up to fourth largest element, right? And when I create the when we basically do the check that length of heap is greater than k, this basically states that heap contains only values which is basically up to kth largest, right? Because if I write 5, then it will store elements in the uh, serialized manner in increasing order, and always the last element would be the largest element in that particular subarray, and the first element would be the minimum element in that particular subarray. Fine. And at the end, we return the top min heap. This is the kth element, kth largest element, you could say. Fine. You could do either min heap top if it is possible. I have written here to better understanding. But in actual, since we have taken the array, we will do min heap 0. Okay, because we want the first index value. Now, what we figured out? We figured out that this problem reduces to maintaining a window of k largest value using a min heap. If you can observe here, if this is an array, we are using a window, right, of size k every time, so that we only get the kth largest element, up to kth largest element, right? And the smallest element in that window will be always our kth largest element. This makes sense. We avoid sorting the whole array, which would take n log n time complexity, right? So I hope you understood the intuition. Now let's move to the next slide. Now, since you got the intuition of the problem, let's look into the approach, how we're going to solve it. Okay, let's do by step one. We initialize the min heap. So we are given an array nums and an integer k, right? We will initialize a min heap of this type, min heap, and it will be a list, right? To track the records of the k largest element seen so far. Python's Heapq module provides the min heap by default. So this how this gonna help or work is basically we have to create a list, okay, in Python. Then secondly, what we have to do is that we have to make heap q, which is what we will use, and we will do heap push, and we will put this value here or this list here, comma the num which we are going to push, right? And this automatically heapifies this particular list. So don't worry about that. This is the way it is done in Python, fine? Because in C++ you could directly use the priority queue. Okay. Now our goal is to maintain the heap size of k, where the smallest element in the heap is the kth largest overall. A mean heap helps to track the top k largest element efficiently. The smallest in the heap will represent the kth largest overall. So I'm saying this line again and again so that it goes to your mind how the intuition is working. Otherwise, it will be difficult for you to understand. Okay. Now, second step will be traversing the array and fill the heap. Okay. What we will do, we will iterate through the complete array, like for num in nums. Okay. What we could do is that we will use heap q. This is a data structure provided by the Python, and its property heap push. Here will be our heap list, and this will be the num which we will gonna push, right? After that, what we can do, we will check if the length of the heap, if it is greater than k, we'll just heap q dot heap pop. We'll just do that, okay, from the main heap. And at the end, what you could do was just you can return the heap which we created. Okay, so this ensures that heap only stores the kth largest element encountered so far, and pushing element ensures all are considered. Removing the smallest when size is greater than k keeps only the top k elements without full storing it. Right. Now in step three, what we could do is extract the kth largest element. This is basically easiest thing you could say. After doing the complete traversal, we just do heap of 0, and we will get our kth largest element. right? Because the heap now holds the kth largest elements, right? In the this list, you could say, right? The smallest of this is the our answer, right? So I hope you understood the approach explanation. This bit is easy and straightforward. Now let's move to the next slide. The code is the exact copy of the approach we discussed. Now let's understand it line by line. So this is the main heap which we will create. This is the traversal which we will do. We'll push the this value into the main heap. The length is greater than k. We'll just pop from the main heap, and at the end we'll return the main heap 0. It's pretty straightforward and simple, right? We already got the intuition of for it. The time complexity comes out to be n log k. This log k is the time complexity of heap, right? Because if you remember, inserting and deleting in heap takes log n time, log n, fine. But since here we are only considered k elements, therefore it is log of k. And n there it is because we are traversing the all the values in the nums, right? This is the n. The traversal of complete array takes n time complexity. Log k takes the popping time complexity or inserting time complexity. You could say that, fine. Space complexity is O of k because in the list here we are storing at most k elements in it, right? So I hope you understood the time and space complexity. It was pretty easy to understand. So let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. I've already brought the code here for the better understanding. Now let's do the dry run, fine. So let this be the main heap to us. Okay, let's continue. We will traverse the array. We'll push the first element, which is 3 here in the heap. We will check is the length greater than k. It is 4, right? Since it is not, we will move ahead. Okay. Then we will push to. Now this will keep on getting Heapify again and again, right? When you push, so it will become 2 and 3. Okay. Since again not greater than 4, right? So we will come again. We push 3 here again in the traversal. Again we will check length is greater than k. It is not. Then we got 1. Again it will get Heapify. So it will become 1, 2, 3, and 3. Is it greater than 4? No, it is equal to 4. Then we got 2. Again, it will get Heapify, right? Now, is the length greater than 4 now? Yes, it is now greater than 4. What we will do? We will pop the min heap element. So it will pop the first element from here. Done. Great. We will move ahead. It is 4 now. We'll push it into the min heap. We will check is it greater than 4? Yes, it is greater than 4. We will pop the topmost value. Done. Then we'll go back. We will consider this value. We'll push the value in the min heap again. It is 5 in this case now. What is the length? It's 5, right? It is greater than 4. Okay, we could say. We'll pop the topmost element, right? Again, we will move ahead. We'll come back to this line, right? We push the value again in the heap. Again, the length is greater than the k. Since it is 5 now, we'll push, pop the value. Again, we will move. We'll push it in the minute. Now, again, the length is greater than 4, or the k, you could say here. Again, we will pop the value. Now, after that, the iteration gets complete because we have completely traversed the array, and we will return min heap 0, which is 4 in this case, right? Is this our answer? Yes, this is our answer. Let me recheck. 6 is the largest, 5 is the second largest, 5 again is the third largest, 4 comes out to be the fourth largest, and after that, fifth largest is 3, sixth is 3, seventh is 2, eighth is 2, ninth is 1, right? So our intuition and dry run worked properly and we got the solution. So I hope you understood the dry run. It is pretty simple and straightforward. But if you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition and the approach, the code, and also the concept of mean and max heap, how it works. After that, do a dry run by yourself with 2, 3 examples. And I'm pretty sure you will understand both the solution and the thought process behind it. So now let's move to the next slide. Now, since you're familiar with the problem and the solution, let's move to the lead code and code the solution. Let's start by initializing a main heap list. Okay. For nums in nums given to us, we'll use the data structure provided by Python Heapq. This will do the Heapify method. Okay. Heap push in min heap value num. Okay, if the length of the min heap crosses the k or greater than k, we'll just pop the value, which is the smallest one basically, right? Min heap. And at the end, we will return min heap 0. Let's try submitting the sample test cases. Okay, now let's submit the finally all the test cases. So we have successfully submitted our solution. Now code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.